Alright guys, so today we're going to be practicing solving systems of equations using the elimination method. So previously we've gone over solving systems of equations using graphing and creating a table, finding the one x value that gives you the same y value for both equations, and then next we used the substitution where we just manipulated one equation of my system and then substituted it into the second one. Today we're going to use something called the elimination method. So for example, can I have equivalent equations using rules of equality? We previously talked about in class equations. As long as you do everything, if you treat everything from the left side and the right side equally, you will have equivalent equations. What I mean by that is if I multiply this entire equation by 2, I eventually have 6x plus 8 is equal to 10. These two are equivalent to each other because if I divide each of these terms by 2, I get the original equation. So these are multiples of each other. If I do the same thing with this one, if I multiply that by 2, I get 12x plus 16 plus 20. Again, these two are therefore equivalent. Equivalent expressions or equivalent equations, just as long as you do everything both equally on the left side and the right side. All right? So let's just jump right in. So because I know that I can manipulate my equations, just like I can manipulate fractions or other rational numbers, we can eliminate them quickly so that we isolate only one variable of our equation. So here we have x plus y is equal to 3, 2x minus y is equal to 0. The coefficient here is 1. The coefficient here is also positive 1. The coefficient here is negative 1. We're going to find the opposites. And luckily, in this example, I have a positive coefficient 1y and a negative 1y. So all I have to do is add the two equations. I eliminate by adding the opposites. So here, I just add vertically. 1x plus 2x is 3x. 1y plus negative 1y is 0y. 3 plus 0 is 3. And because there's 0y, I don't even need to worry about that 0y. So what I really have now is 3x is equal to 3. From here, I divide both sides by 3, and x is 1. And there's my first solution. X is 1. And then what I do is now I take this and I substitute it back in. Now you can substitute it back into any of the equations that you want, but since these are all coefficient of 1, it's just much easier to substitute it into that one. So here I have, this is equation A, this is equation B. Equation A would be, instead of x, I can write 1 plus y is equal to 3, minus 1 from both sides, y is 2. So my solution point is 1, 2. And I better make sure that it works for each of these. So here's equation A. 1 plus 2 equals 3. Check. Equation B. 2 times 1 plus negative 2 is equal to 0. So 2 times 1 is 2, minus 2 is 0. Check. So we use elimination method to eliminate opposites. Now you probably will have a question about, well, what if we have coefficients that aren't always opposites? For example, like this one. 5x plus 4y is equal to 22. Things get a little bit more complicated because right away you can't really eliminate any one of the variables because they're different coefficients. There's no opposites. But we previously talked about equations are very similar to rational numbers where you can have multiples of each other. Well, the same here. Strategy would be, if this is equation A and this is equation B, the first thing you want to do is find a set of x or y that is easy to eliminate. Here I have a coefficient of 1 and positive 4. Well, wouldn't it be cool if this was negative 4 and this was positive 4? And then I can just eliminate the y's and then have x by itself and then solve for x. Well, now we can't. All we have to do is we can actually multiply this entire equation by -4. So then what happens is equation A becomes -12x plus -4y is equal to -36. Now, if I wanted to, I can factor out -4 from each of these. In other words, I can divide -4 in a 12x and get positive 3x. I can divide -4y by -4 and get positive 1y, and then divide -36 by -4 and get positive 9. So that way I am getting an equivalent equation with one another. And then from here, I can just drop down equation B, which is 5x plus 4y is equal to 22. And now that I have my opposites, one of these opposites, I can go ahead and eliminate or just add. Here we have -12x plus 5x becomes -7x. -4y plus 4y is gone, or 0y. I don't have to write that. Is equal to -36 plus 22. That becomes -14. I divide both sides by -7. And x is positive 2. Now that's just one of my points. And then what I'm going to do is, just like before, I am going to take x is equal to 2, and I'm going to substitute it back into one of these. It doesn't matter which one, but you just have to make sure that if you do it, once you find your y value, it has to work for both equations. So I'll just go ahead and substitute it back into equation A. Okay, here I have 3 times 2 plus y is equal to 9. 6 plus y is equal to 9. Subtract 6, y is 3. So my solution point now is x is 2 and y is 3. So I'll quickly check. 3 times 2 is 6 plus 3 is 9. 5 times 2 is 10. 4, so 5 times 2 is 10. 4 times 3 is 12. That equals 22. So it works. So again, right away, this is a little bit different than substitution just because I am multiplying one of the equations by a number so I can create an opposite pair. In class, we'll go over what happens if you have to find a common multiple of each of the equations. That's the same idea. You will have to multiply both the equations and then create your order sets. So please, with this video in your notes, write down any questions. If you can email me and we'll go over in class. Thanks, guys.